In this video, I want to have a look at integration by substitution and specifically look at indefinite integrals. So integration by substitution is the reverse of differentiating using the chain rule. So we're going to use some similar notation and similar ideas. So if you don't remember the formal way that we introduced the chain rule and the notation that we used there, it might be an idea to go back at some stage and have a look at that video that we did. So the aim of integration by substitution is to make an appropriate substitution, and usually that'll be given to you in the question. And that substitution is going to transform the integral that we have into one that involves a more standard result, so into something that we're more familiar with and we can integrate more easily. So let's have a look at some examples. So our first example asks us to find the integral of x to the power of 4 outside of 2x to the power of 5 minus 1 all cubed with respect to x. And we're asked to use the substitution u equals 2x to the power of 5 minus 1. So that's this bit here in brackets. So the first thing you're going to do off to the side, if we know that u is equal to 2x to the power of 5 minus 1, then we're going to differentiate u with respect to x. So we're going to differentiate this function. And in this case, that's going to give us 10x to the power of 4. Now, if we rearrange that, and you'll see why we're going to do this in just a minute, we're going to rearrange this to get du on its own. So we're going to have du equals, and we're going to multiply by dx. So we're going to have 10x to the power of 4 dx. So du is equal to 10x to the power of 4 dx, and that's going to come in handy in a minute. So if we're finding this integral, then it's going to be equal to x to the power of 4, and I'm going to replace this whole bit here with my u, because 2x to the power of 5 minus 1 is u. So I'm going to have x to the power of 4 u cubed dx. But the problem at the moment is now I have x's and u's and a dx, and having two different variables in there isn't going to work. But what we can do is we can use this bit here. So that x to the power of 4 dx, that's here and here. So what we're going to do is we're going to manipulate it so that we also have this 10 in the front as well. So I'm going to rewrite this as the integral of 10x to the 4 u cubed dx. But I can't just introduce a 10, so to compensate for that, I'm going to put 1/10 out the front. So now this whole section here, this 10x to the 4 dx, all of that can be replaced by this du. So that's going to give me 1 over 10 times the integral of u cubed du. So now I've got one variable, u, and now it's looking like a pretty standard integral. So if I integrate that, I'm going to have 1 over 10 times, if I integrate u to cubed, I'm going to have u to the power of 4 over 4 plus c. And if I simplify that, I can have u to the power of 4 over 40 plus c. So I've integrated it, but the last step that I want to do is put it back in the same variable that the question came in. So I want to have x's in there instead of u's. So I'm going to put this back in where that u is. So the last step, I'm just going to write it next to it because I don't have room down the bottom, is going to be 2x to the power of 5 minus 1, all to the power of 4, over 40 plus c. Let's have a look at a second example. Our second example asks us to find the integral of x times the square root of 1 plus x squared dx using the substitution u equals 1 plus x squared. So again, we'll start off to the side by just writing down what our substitution is going to be. That means that du dx would give us 2x, which means that du would be equal to 2x dx. So now if we rewrite this, that's going to give me the integral of x times the square root of u, because that 1 plus x squared is my u, and that's dx. But this 2x dx, most of that is here. We've got an x dx, but we need to manipulate it so it has that 2 as well. So if I change that to a 2x root u dx, then I would have to put a half out the front to compensate for that 2. And then this whole 2x dx is going to be replaced with du. So then I would have a half times the integral of the square root of u du. And now we can integrate like normal. So I'm going to rewrite that first to have u to the power of a half du. If I integrate, I'm going to have a half times u to the power of 3 over 2. And I can divide by 3 over 2, but I'm going to write it as 2 over 3 instead, multiplied by the reciprocal, and then plus c. Now my 2's will cancel, so I'll end up with u to the power of 3 over 2. Actually, I'm going to rewrite that to the square root of u cubed instead, over 3 plus c. And then again, the last step is substituting back the other direction. So substituting, instead of this u, putting that 1 plus x squared back in. So we're going to have the square root of 1 plus x squared, all cubed, over 3 plus c. So there are a lot more examples of integration by substitution for indefinite integrals in both of your textbooks if you need to have a look at a few more run-throughs of the process. But those are two examples of integration by substitution.